Naive, as I said before, we assume that the next period will be the same as the previous one. There's no magic there. In moving averages, we tend to say, okay, we take the last 2, 3, 5, whatever periods we define, and we get the average. Tomorrow we'll grab the last n periods. So for example, if today is, let's say, Monday, and we're always using the last 2 days, for Monday we will use Saturday and Sunday. For Tuesday we will use Sunday and Monday. And for Wednesday we will be using Monday and Tuesday as the information points. The next one is weighted moving averages, which is exactly the same, but where we will be putting weight assigned to each period. Why? Because we tend to think that the latest value is the most important. So for example, we assign to yesterday's number a higher weight than for the day before. Now, some problems with moving averages is that while we increase the number of periods that we take, it gives us a better smoothing. Yes, it reduces fluctuations, but it's so much less sensitive to changes in the numbers that compromise a time series. Moving averages are not good at capturing trends. Then we have exponential smoothing, a model that you most certainly have seen previously in statistics and probability courses. We take the forecast, or we create the forecast for our, let's see, here's the pen. We create our forecast for period t by using the forecast that we had for the previous period plus an alpha, which is a smoothing constant, that multiplies this difference that we have between the actual and what we had forecast. So this difference is the error which we smooth with this constant, which we add to our forecast. We're taking into account the error that is present. Then we have trends. We adjust the time series and we project it into the future, but we keep in mind the trend. Finally, we have linear regression, something that you have seen since secondary school, which is the simplest method to generate a line. We use the general equations, which you already know from high school, regarding your just one second here, pen. This is the general line equation. We're talking about this is the m, which is the slope. This is the origin, x-axis, and we have this equation to calculate m. Then we have our correlation analysis, which is the relationship between the behavior of one variable and the behavior of the other variable. And the correlation index R is calculated with its formula. What we're interested in right now is that there are 4 possible correlation coefficient values. R equals to 1, which is a perfect positive correlation, a positive correlation between when R is between 0 and 1, a non-existent correlation when R is equal to 0, and a perfect negative correlation when R is equal to -1. In graphical terms, we're talking about when R is equal to 1, all our observations will be exactly on top of our projection. When R is between 0 and 1, our observations will be close to our projected behavior, but not exactly. That's why it's less than 1. When we have an R of 0, well, our observations are all over the graph, but there's no correlation with what we projected. And with -1, it helps us a lot, because even though the behavior is completely negative, it is exactly completely negative. So we know what is going on. So, checking again our 4 possible correlation coefficient variables. Perfect possible correlation is R equals to 1. Positive is between 0 and 1. Non-existent is equal to 0, and perfect negative correlation is -1. But remember always, correlation does not imply causation. One thing is that 2 variables are correlated, but another thing is that one implies that the other must happen in this way. Correlation does not imply causation. Let me underline this. It does not imply causation. Please do not forget this. So, what have we seen in this video? What is forecasting? A manner of prediction. What are the differences with provision? Uncertainty. How are forecasts made? For the short, medium, and long term. What types of forecasts? We've checked economic, technological, demand, supply, environmental, political, social, etc. What are the stages in forecasting? What is the law of large numbers? We checked out the forecasting approaches, both quantitative and qualitative. We checked out time series components, tendencies, seasonalities, cycles, random variations. And we checked out a little bit about quantitative methods and qualitative methods before remembering everything about correlation analysis and what the R means for us. Thank you for your attention to this video, and we will be seeing each other in the following videos for this series.